Hello everyone. In this video, we'll see types of machine learning. So machine learning is the science of making computers to act by feeding them some data and making them learn a few tricks on their own. That is without being explicitly programmed. Now this definitely sounds a lot like a human child. Now as a child, if you had to distinguish between fruits such as banana, apple and oranges, you wouldn't even know where to start because you are not even familiar with how the fruits look. So, as we grow up, we collect more information and start developing the capability to distinguish between various fruits. The only reason why we are able to make this distinction because we observe our surrounding and gather more data and learn from our past experiences. Because our brain is capable to make decisions since we have been feeding in a lot of information and a lot of data, and this is exactly how machine learning works. So now let's get into type of machine learning. There are majorly three types of machine learning that we are going to look into. So there are majorly three types of machine learning. These are supervised, unsupervised and reinforcement learning. Therefore, let's discuss each one. First of is supervised learning. The reason it's called supervised learning because this setting assumes that to train the machine learning algorithm, a human teacher gives it a set of examples of what the teacher expects to get from the algorithm after the training is done. The set consists of pair of attributes and right labels. That is, you know your x and y, your input and output variable. An example would be that you want to predict a price of a house in your area. Therefore, your training set would consist of size of the house with its price. So your input and output are both labeled because you are trying to supply the size and price to computer and making it learn, predict the price of the house. Now let's look at unsupervised learning. The reason it's called unsupervised is that here only examples with attributes X are given. That is just the data without any label. So there is no teacher to provide class labels. Unsupervised learning allows us to approach problems with little or no idea of what our results should look like. We can derive structure from data where we don't necessarily know the effect of the variables. An example would be an adult that need to be guided and have the ability to figure things out on their own without any supervision, unlike supervised learning where the machine is fed labeled data and explicitly telling them, hey, this is the input and this is how the output should look. Here the machine has to find the pattern in the data on their own. And finally, third type of learning from experience is called reinforcement learning. This case is in the sense intermediate between the two previous cases. There is a teacher, but this teacher only gives a partial feedback on the performance of the machine learning agent. The feedback comes through rewards received by the agent when performing actions. Reinforcement means to establish or encourage a pattern or a behavior. Let's say you have been dropped at an isolated island. Then what would you do? Well, initially you would panic, obviously. And after that, because you're unsure of what to do, from where to get food or how to live and so on. But after a while, you will have to adapt. You must learn to live in the island, adapt to the changes in the climate and learn what to eat and what not to eat. So here you are basically following the hit and trial concept because you are new to the surrounding, and the only way to learn and basically learn from your experience. So you will be rewarded for right actions and penalized for wrong actions and accordingly build experience. So the classification for machine learning algorithm into supervised, unsupervised and reinforcement learning is probably most fundamental ontology of machine learning. A vast majority of practical algorithms that are applicable to machine learning techniques fall into one of these categories. Now let's further classify these. Well, supervised learning problems are categorized into regression and classification problems. In a regression problem, we are trying to predict results within a continuous output, meaning that we are trying to map input variables to some continuous function. In a classification problem, We are instead trying to predict results in a discrete output. In other words, we are trying to map input variables into discrete categories. Now, classification is about predicting a label or a class, whereas regression is predicting a continuous quantity. Let's say that you have to classify your emails into two different groups. So here we will be labeling our emails as spam or not spam mails. For this kind of problem where we have to label our input data, we make use of classification algorithm. As for regression, this will be used to predict a continuous value. A continuous variable would have infinite number of possibilities. For example, a person's weight. So someone could weigh 180 pounds or could be 180.1 pounds or 180.3 pounds and so on. So the number of possibilities of weight are limitless, and this is exactly what our continuous variable. So regression is a predictive analysis used to predict a continuous variable like stock prices, house prices, etc. Here you do not have to label data into different classes. Instead, you have to predict the final outcome like price of Apple stock in 1 month time, etc. Can be used to solve association problem or clustering problem. Now, association problems basically involves discovering patterns in data, finding co-occurrence and so on. A classic example of association problem would be a relationship between bread and jam. So people who tend to buy bread also tend to buy jam. Over here, it is all about finding associations about items that frequently co-occur or items that are or that are similar to each other. Now, apart from association problem, unsupervised learning also deals with clustering and anomaly detection problem. Now, clustering is used for problems that involve target marketing, wherein you are given a list of customers and some information about them. And what you have to do is you have to cluster these customers based on their similarities. For example, you are given news articles and the algorithm will cluster these into different types of news. Examples would be political news will form one cluster, economic news will go into another cluster, sport news will go into another cluster, and so on. Now, algorithm could be given a set of images and it would cluster them into different objects. Example, males in one cluster and female into another. Now, anomaly detection, on the other hand, is used for tracking unusual activities. Example of this could be credit card fraud, wherein various unsupervised algorithms are used to detect suspicious activities. Now let's look into reinforcement learning. This learning is comparatively different. The difference is that the input itself depends upon the actions we take. For example, in robotics, the robot initially wouldn't know anything about its surrounding. After it performs certain actions, then it finds out more about the world. But world, you see, depends upon whether it chooses to move right, left, forward, or backward. In this case, the robot is known as the agent, and its surroundings is known as environment. So for each action it takes, it might receive a reward or a punishment. All right, so that's all for this video, guys. In the next video, we'll see how each of these types are used in financial industry. Thank you for listening.